Okay, here's the top view of the rotor and a side view of it. I had screws on the top. They were held in place by magnets. I'd feed the negative voltage in from the bottom and the positive voltage in from the top, and this thing would rotate like that. And the front wire had a thin corona wire going across the front, and that has since broken off on these, so I'm going to repair this thing. And this is just made out of plumbing supplies, and it would of course rotate like that. And what the idea was is I wanted to stick it inside of an enclosure to see if the device actually violates conservation of momentum. Now, to be fair about the whole thing, Towsend Browns in his patent did say that you have to have a high dielectric in between the positive and negative capacitor plates in order to produce the effect that he was talking about, the electrogravitic effect. But I just wanted to do some experiments to test this to see if this did violate conservation of momentum, and that's what this video is going to be about. Okay, hello, this is Dr. Jaynes, and today I'm going to talk about some more electrodynamic propulsion experiments that I've carried out. Here's a rotor, and did these experiments a while back. The wires have actually broken, but okay. Today's date is 9. This is my lifter carousel experiment. I turn on the power, and you see there's a transient. The lifter rotates, and then it comes back to a positive DC offset. We'll let it sit for a little while, and we'll turn the power off. Now there's a transient back the other way, and then it comes back to 0. Okay, today is 9602, and this is lifter carousel. I'll turn on the power. You see the carousel rotates to the left, has a transient overshoot, and then it settles down to a positive DC offset. Let it sit there for a second. Okay, it's now settled down. I'll turn the power off. Has a transient back past the 0 point, and it comes to rest at 0. Okay, I did have a question as to whether the transients were moving the air around, and due to momentum and such, that were causing the carousel to rotate and then stay in the positive DC position, basically due to the transients. So what I'm going to do is I'm going to eliminate the transients by putting a little block down here to stop the rotor from moving when I turn on the power. Okay, I turn down the okay. In order to prevent, to rule out any transients, I've put a little block down here to prevent the rotor from moving during startup. Okay, I've turned on the power. Now I'll remove the block. Okay, in order to take out the transients of the measurements to show that there really is a DC offset and a electrogravitic effect, I put a little block here to prevent the the carousel from moving during startup. Turn the power on. Now remove the block. Okay, the rotor's at stable equilibrium. I put on the brake. I'll turn on the power and let it reach a stable equilibrium. Move the brake. Put the brake back on. Okay, the rotor is in a stable equilibrium. I will on a brake. Oh shoot. Okay, right now the rotor's in a stable equilibrium. I'll put on the brake. Okay, the rotor is in a stable equilibrium. I'll put on the brake to hold it in place during the transients. Okay, I turn up the power, and I remove the brake. And it has a steady DC offset. Okay, I'll put the brake back on, turn off the power, and the rotor returns back to 0. Or approximately 0. It shows that there is a definite thrust. It's not due to the transients of the air starting and stopping to move. Here's a side view of the lifter carousel. Here's a side view without the pointer.